What if your network was stuck using 30-year-old technology? RIP routing still works, but is it secretly crippling your network? In this video, I'll expose the truth about RIP and why it's both genius and dangerous. Want to understand dynamic routing fundamentals? Let's dive in. RIP distance vector routing protocol. Even if the RIP protocol is very old and little used, it is still important to talk about it to better understand the principle of dynamic routing. The RIP protocol exists in 3 versions. There is RIP v1, which uses the default masks of the IP classes. RIP v2, which allows the use of modified masks. And RIPng for IPv6. It is a standardized protocol that is part of the IGP protocols, i.e. internal routing. It sends its neighbor routers every 30 seconds its complete routing table using split horizon and route poisoning. The split horizon allows you to transmit to your neighbors only the networks that are not directly connected to it. For example, on this topology, the routing table of router 1 includes the networks that are directly connected to it, and also those that have been learned by the RIP protocol, i.e. the networks at the other end. On router 2, it's the same. We can clearly see its 2 networks that are directly connected to it, and the 192.168.10.0 network that is behind router ats. Like RIP update from router 1 to 2, will include all the networks that router 1 is familiar with, but also the networks that router 2 is already familiar with, since they are directly connected to it. Thanks to the split horizon, it will send only the useful networks, which router 2 needs. Basically, the split horizon makes sure not to transmit unnecessary information to its neighbors. This reduces bandwidth. Route poisoning is used to remove unavailable networks from the routing tables. For example, if the network 192.168.10.1 becomes unavailable, a RIP update will start from router 1 to notify router 2 with an infinite metric for that unavailable network. The infinite metric for RIP is 16. This way, if packets arrive at this network on router 2, it will allow it to delete it directly without passing it to router 1. Now let's move on to setting up RIP. The router RIP command activates the protocol. By default, it is in version 1. To activate RIPv2, simply type the command version 2. And the network command allows you to search for new neighbors of these networks and to declare them in your updates to your neighbors. And here, now is what our routing tables would look like. On router 1, we see a RIP line that says that to join the network on the far right, you have to go through the 0.1 interface of router 2, the one with the IP 192.168.0.2. And for router 2, it's the same thing. You can see your networks that are directly connected to it, and in RIP you have the 192.168.10.0 network, which can be reached via the IP 192.168.0.1. On the RIP line, the number 120 is the administrative distance, and the 1 is the metric. Routers that work with the RIP protocol periodically send update messages. These messages are sent every 30 seconds. And if one of the routers does not receive an update, then it will have the effect of triggering different types of timers. If after 30 seconds it does not receive its update, then the timer invalid is triggered. After 180 seconds, the route is considered invalid and placed in hold-down mode. In this mode, updates to that route will be ignored for 180 seconds unless it gets a lower metric. And on the other hand, if after 240 seconds the route is still unavailable, then it will be removed from the routing table.